Hello, and welcome to this month's VideoTec. Last month, our engineer gave you an overview of the theory of operation behind the sequential MPI fuel injection system used on Jeep vehicles with 2.5 and 4-liter engines. This month, I'll be showing you some of the techniques for diagnosing faults in the fuel injection system. But before we get going, let's take a look at some of the tools you'll need to carry out these procedures. There are a lot of changes in the 91 fuel injection system from last year, so it's important that you refer to the new service publications before attempting any repairs. 3 publications that I especially recommend are the 1991 Jeep Engine, Chassis, and Body Service Manual, the 2.5 and the 4-liter Sequential Fuel Injection Student Reference Guide, and the 1991 Powertrain Diagnostic Manual. A lot of the theory of operation behind the fuel injection system shown last month is spelled out in even more detail in the 91 Service Manual and the Student Reference Guide. All of the diagnostic procedures you'll be seeing in this VideoTec program can be found in the 91 Powertrain Diagnostic Manual. And of course, one of the most important diagnostic tools we'll be using is the DRBII and the new 1991 cartridge. You'll find some pretty major changes in both the operation and capabilities of the new cartridge. For example, for the first time on Jeep models, the engine controller stores faults. And with the new cartridge, the DRBII now features 2-line fault messages, which are more descriptive than in previous years. Later in the program, I'll be showing you how to use the DRBII to access those stored faults. There are also major changes in some of the manuals. The diagnostic manual has changed to a clearer, easier to read format, and for the first time includes a section on no-fault drivability. It also includes a new section called Helpful Information. So you can see there are changes not only in the fuel injection system, but also in the diagnostic tools used to troubleshoot the system. When we come back, I'll be taking you through a general diagnosis of the fuel injection system, beginning with a visual inspection. Whenever a customer brings in a car with a drivability complaint, you should always make a note of the symptoms and then do a careful visual inspection for loose, disconnected, or incorrectly routed wires and hoses before attempting to diagnose or service the fuel injection system. This is where the brain of the fuel injection system, the engine controller, is located on Cherokee and Comanche models. On Wrangler models, the engine controller is located here, behind the washer fluid reservoir. It's important to remember that what we're dealing with is a fuel injection system, a system that's made up of various input sensors and output actuators, all of which are controlled by the engine controller. If there's a problem with the fuel injection system, don't just assume that the engine controller is faulty and needs to be replaced. The cause of poor drivability or a no-start condition may be a bad connection or a faulty sensor or actuator, and not a bad engine controller. One of the first steps in a thorough visual inspection is to check that the 60-way connector is fully inserted into the engine controller and that the mounting screw is tightened down. After all the fault messages have been read, it's a good idea to remove the 60-way connector and check the engine controller and the connector for damaged pins or pushed-out terminals. On the engine controller 60-way connector, a terminal is pushed over a pin. It's important to check the connector carefully. It's possible for the terminal to be pushed out, preventing the pin from making a proper connection. A number 54 drill bit or a 55 thousandths inch drill gauge can be used to check terminal size. You should feel resistance as the drill gauge is pushed in or pulled out of the terminal. If you don't, the terminal tabs have been spread too far and the terminal should be repaired. If the engine controller connector passes a visual inspection, you can then move on to inspecting the rest of the system's components. Be sure to check all the electrical connections and vacuum lines used on the sensor inputs for the engine controller. Here's a sample of what to check for when performing a visual inspection. On inputs such as the MAP sensor, check the electrical connector. Also verify that the vacuum hose is connected to the sensor and to the intake manifold. Check the ignition coil connections and verify that the coil wire is connected to the distributor. Check the throttle position sensor electrical connector. This is especially important if the vehicle has been worked on recently. The TPS connector only goes on one way. Check the output connections in the same way, such as the connections on the idle speed motor. And make sure that the fuel injector wire harness connectors are connected to the fuel injectors in the correct order. Each harness connector is tagged with the number of its corresponding injector at the factory. Also be sure to check items which are not inputs or outputs, such as the engine ground strap connection and the system ground connection located behind the dipstick. In each case, the connection must be tight and free of corrosion. Also check vacuum lines, such as the brake vacuum booster hose and the fuel pressure regulator vacuum hose. It's also important to check for fuel leaks at the quick connect fuel rail connections and at all other fuel lines. That was just a brief sampling of things to check for while performing a visual inspection. The 1991 Engine, Chassis, and Body Service Manual and the Helpful Information section of the 1991 Powertrain Diagnostic Manual each contain a list of the electrical connectors, vacuum, and fuel lines that should be checked. If engine performance is poor and a visual inspection fails to reveal a cause, the next step is to use the onboard diagnostic capabilities of the engine controller to check for faults. The engine controller of Jeep Cherokee, Comanche, and Wrangler models has been programmed to monitor many different circuits on the fuel injection system. If a problem is sensed in a monitored circuit often enough to indicate an actual problem, a fault is stored in the engine controller memory. If the problem is repaired or ceases to exist, the engine controller cancels the fault upon the 51st engine start. A circuit is not monitored for faults at all times and under all conditions. Certain criteria called arming conditions must be met for a fault to be entered into the engine controller memory. Arming conditions are time intervals, temperatures, or engine conditions. And arming conditions are different for each circuit. It's possible that a fault for a monitored circuit may not be entered into memory even though a malfunction has occurred. This may happen because one of the arming conditions for the circuit hasn't been met. As an example, let's look at the MAP sensor circuit. Now let's assume that one of the arming conditions or fault criteria for the MAP sensor circuit is that the engine must be operating between 400 and 1500 RPM to be monitored for a fault. First, we check for fault messages and find that the DRBII screen reads no faults. We'll simulate a fault by taking a jumper wire and back probing the MAP sensor at the output wire. Then we'll start the car and raise the engine speed above 1500 RPM so that we'll be outside the arming conditions for the MAP sensor electrical fault. When we ground the jumper wire, the DRBII shows that no fault messages are set. However, you can hear the engine reacting to the low MAP sensor voltage. When we read MAP sensor voltage while grounding the output wire, the reading goes to 0 volts. There's obviously a problem. But a fault will not be entered into the memory because the condition does not occur within the RPM range monitored by the arming conditions. In order to fully understand the onboard diagnostic capabilities of the fuel injection system, you need to know what systems the engine controller monitors and what it doesn't monitor. The engine controller can detect certain fault conditions in the fuel injection system. For example, the engine controller can determine if sensor output is within a proper range and if the circuit is open or shorted. It can also sense whether input devices, such as the engine coolant sensor, are hooked up. If there is a problem with the circuit, the controller senses whether the circuit is shorted or grounded. The engine controller can determine if the oxygen sensor is switching between rich and lean once closed loop has begun. Now that's a brief look at just some of the circuits the engine controller can detect faults in. Now let's look at some of the systems the engine controller cannot detect faults in, the non-monitored circuits. There are a number of circuits and systems that are not directly monitored by the engine controller, but those systems could have malfunctions that cause drivability problems. It's also very important to remember that a problem in a non-monitored system may cause a fault to be displayed in a monitored system. For example, the engine controller does not monitor fuel pressure. High or low fuel pressure can be caused by a clogged fuel pump inlet filter, a clogged inline fuel filter, or a pinched fuel supply or return line. However, these could result in a rich or lean condition causing an oxygen sensor fault to be stored in the engine controller. Secondary ignition is not monitored. Problems with an inoperative ignition coil, foul or worn spark plugs, cross-firing, or open spark plug cables will not be detected. The engine controller cannot detect if ignition or cam timing is retarded or advanced, or if cylinder compression is too high, too low, or uneven. The exhaust system could be leaking or have a plug converter. The engine controller cannot determine if a fuel injector is clogged or has a sticking pintle, or if the wrong injector is installed. These conditions could cause a rich or lean condition causing an oxygen sensor fault to be stored in the engine controller. Excessive oil consumption is also not monitored, although oil in the exhaust stream can cause the oxygen sensor to produce incorrect mixture readings. The engine controller does not monitor if the throttle body airflow is out of spec because of a clogged or restricted air cleaner inlet or filter element, but this can result in an oxygen sensor fault. The engine controller will not detect a fault in an evaporative purge canister that is restricted, plugged, or loaded with liquid fuel. It will not detect leaks or restrictions in the vacuum circuits of vacuum-assisted engine control systems. However, these could result in the setting of a MAP sensor fault. Poor grounds or no grounds will also not be detected, although a fault may be generated as a result of this condition. The engine controller connector terminals could be spread apart, crushed, or pushed out. Again, this condition could cause a fault to be stored in the engine controller, but the fault would not indicate lack of a ground. As you can see, to correctly diagnose the source of a fuel injection problem, you need to know what circuits are monitored or are not monitored, and understand that a fault code can be set by a malfunction in either type of circuit. Next, we'll look at two ways of accessing those stored faults. The check engine lamp will display fault codes. The DRBII will display fault messages. In last month's program, we showed you one way of retrieving fault codes by cycling the ignition switch on within 5 seconds. The check engine lamp will then display any stored fault codes in a series of flashes representing numbers. An exact description of the fault condition can then be obtained by looking up the fault code in the service manual or the student reference guide. The preferred way of retrieving fault messages is by using the DRBII. The DRBII connects to the fuel injection system through the diagnostic connector located here on Wrangler models and here on Comanche and Cherokee models. To power up the system, turn the vehicle's ignition key to the on position. The first thing you'll see on the DRBII screen is the program version number and Chrysler Motors copyright message. This screen will appear next. Press the down arrow to view the rest of the screen. Choose Select System to enter the diagnostic test program. Then select Engine to enter the engine system part of the DRBII program. The display will read like this for a few seconds, then change to this screen. This screen asks you if the vehicle is equipped with air conditioning. Our vehicle isn't, so number 2, without AC, is selected. Selecting fuel ignition brings up a menu of DRBII test categories for the fuel and ignition systems. We can then read any fault messages pertaining to the fuel system by selecting Read Faults. If there are no fault messages, the display will read like this. If there are fault messages, a typical display will appear something like this. The exact numbers displayed will vary depending on how many faults there are and how many starts there have been since the fault was set. After all the fault messages have been read and the necessary repairs have been made, you should erase the fault messages. Refer to the Helpful Information section of the 1991 Powertrain Diagnostic Manual for the proper procedure. That was a brief look at how to move through the menus using the new DRBII cartridge. You'll find more complete instructions on its use in the Helpful Information section of the 1991 Powertrain Diagnostic Manual. Well, now that you understand how faults are set and how to access them, let's take a look at a few sample conditions that involve troubleshooting fuel injection system faults using the DRBII and the 1991 Powertrain Diagnostic Manual. We'll be using a Wrangler for our first problem, a no-start condition with a fault message. We'll start with test NS1A in the Powertrain Diagnostic Manual. Test NS1A first instructs you to ensure that the battery is fully charged. It then instructs you to turn the ignition key to the on position and use the DRBII to access any stored fault messages. If the DRBII display showed no response, then test NS1A instructs you to perform test NS8A, a test of the throttle position and map sensors. But if the no response message persists, refer to the 1991 Vehicle Communications Manual. But in this case, the DRBII showed a fault message for the auto shutdown relay. So test NS1A instructs you to perform test NS10A, a check of the ASD relay and the wire harness leads to the relay. Test NS10A asks you to make sure the ignition key is in the on position, and then to disconnect the auto shutdown relay and inspect the condition of the harness connector. Be especially careful to check for bent, crushed, pushed out, or otherwise damaged terminals. But if the connector is in good condition, test NS10A instructs you to put the DRBII in the voltmeter mode and probe the yellow wire. If the voltage is not above 10 volts, there is an open in the yellow wire from the ignition switch. But if the voltage was above 10 volts, the lead from the ignition switch is good. The next step is to test the resistance across the ASD relay terminal using an external ohm meter. If the resistance is above 100 ohms, the auto shutdown relay is faulty and needs to be replaced. But if the relay resistance was below 100 ohms, turn the key to the off position, then disconnect the engine controller connector and inspect the controller and the connector as shown earlier for damaged pins or pushed out terminals. If the connector is damaged, repair it. If the connector is in good condition, test NS10A instructs you to use an external ohm meter to check the resistance of the orange wire with the dark green tracer. If the resistance is above 10 ohms, there is an open in the wire. Repair the wire and retest the system. But if the resistance is below 10 ohms, the problem lies in a faulty engine controller. You should replace the engine controller and retest the system. Our next diagnostic test involves a drivability problem where there is a fault message present. Our troubleshooting will begin with test DR1 in the Powertrain Diagnostic Manual. Test DR1 asks you to make sure that the battery is fully charged, then tells you to check for fault messages using the DRBII. In the case of this Cherokee, the DRBII shows a problem with the number 1 injector control circuit and tells you to proceed to test DR16A. Test DR16A tells you to turn the ignition key to the off position, then disconnect the number 1 injector connector. Make a careful visual inspection of the connector. If the connector is damaged, make the necessary repair. But if the connector is in good condition, turn the ignition key to the on position and use the DRBII to actuate fuel injector circuit number 1. Then put the DRBII in the voltmeter mode by pressing volt ohm once and touch the test probe to the connector of the dark green wire with orange tracer. If the voltage reads 0 or less than 10 volts, there is an open in the probed wire. Repair the wire and retest the system. But if the voltage reads above 10 volts, check the control side of the circuit next. To do this, press the volt ohm button again to put the DRBII in the ohm meter mode and probe the white wire with dark blue tracer. If you get a resistance reading of less than 10 ohms, you need to check the control circuit for a short to ground. To do this, disconnect the engine controller connector and check for a short to ground by probing the white wire with dark blue tracer. If you now get a reading of less than 10 ohms, there is a short to ground in the probed wire. Repair the short and retest the system. If, however, you obtained a resistance reading above 10 ohms, there is a fault in the engine controller. Replace the controller and retest the system. But if, when you first probed the white wire with dark blue tracer, the resistance was higher than 10 ohms, you need to check the control circuit for an open. To do this, you should disconnect the engine controller connector and use an external ohm meter to check the resistance of the wiring harness between the engine controller connector and the injector connector by probing terminal number 16 of the engine controller connector and the white wire with dark blue tracer. If the resistance is above 10 ohms, there is an open in the wire. You'll need to repair the wire. If the resistance is less than 10 ohms, the problem lies in a faulty engine controller. Again, you'll need to replace the engine controller. Suppose a customer brought in a vehicle with an obvious drivability problem, the engine running rough or missing. And yet, when you performed test DR1, the DRBII showed that no fault had been set in the engine controller. In that case, test DR1 instructs you to start the vehicle and allow the engine to reach normal operating temperature. Manually set the engine speed to 2,000 RPM for at least 10 seconds. Note, don't use the DRBII to do this. Then return the engine to idle speed. If the vehicle is equipped with air conditioning, put the fan on low speed and turn the air conditioning on. If the vehicle stalls when air conditioning is turned on, you'll need to remove and inspect the engine controller connector with the ignition off. If that checks out good, you'll need to turn the ignition key to the on position and use the DRBII in the voltmeter mode to probe cavity number 9 of the engine controller connector, the battery feed to the engine controller, for a 10-volt signal. If you obtained a reading below 10 volts when probing cavity number 9, you'll need to repair an open in the dark blue wire. If you got more than 10 volts, the engine controller is faulty and should be replaced. If the vehicle did not stall when you turned on the air conditioning, in an automatic equipped vehicle, you should hold the vehicle with the foot brake with the engine running and shift the transmission through all gears before returning it to park, and then use the DRBII to read fault messages. If there are no fault messages, you should check all technical service bulletins and hotline newsletters that relate to this drivability problem. If there isn't a pertinent TSB or newsletter, Test DR1 directs you to perform Test DR26A, the first in a series of no-fault drivability diagnostic tests. After performing the tests in the no-fault drivability section, you will have determined that all of the engine control systems are operating as designed and are not the cause of the drivability problem. What remains is a check of the mechanical systems as a possible cause of the drivability problem. Your check of the mechanical systems should include engine vacuum, which must be at least 13 inches with the vehicle in neutral, engine valve timing, engine compression, the engine exhaust system, which should be free of any restrictions, the engine CCV system, engine drive sprockets, torque converter stall speed, power brake booster, the fuel, which should be free of high water and alcohol content, and fuel injectors, which could be plugged or restricted. The 1991 service manual contains a procedure for diagnosing fuel injector problems in vehicles with a drivability problem. We'll use part of this diagnostic procedure to diagnose the problem. The first step is to start the vehicle, and with the engine running, disconnect and connect the electrical connectors on the fuel injectors one at a time to determine which cylinder is not firing. Injector resistance is tested by removing the connector and connecting an ohm meter across the injector terminals. The resistance should be approximately 14.5 ohms. If it isn't, the injector is faulty and should be replaced. In our case, the resistance is correct. The next step is to make sure that fuel is being delivered to the injector. To do this, it's necessary to remove the fuel injector from the rail. However, before we can remove the injector, it's vitally important that we carry out the MPI fuel pressure release procedures outlined in the service manual. With the fuel pressure released, we can then remove the suspect injector from the fuel rail and check for fuel in the rail. If the rail is plugged or restricted at the injector delivery coupling, it should be replaced. Also, check the injector. If the injector is plugged or in any way restricted, replace it. Jeep fuel injection systems use state-of-the-art electronics, but you shouldn't let their sophistication scare you. Thanks to the new DRBII cartridge and publications such as the service manual and the powertrain diagnostic manual, diagnosing a no-start or drivability problem is simply a matter of following the diagnostic path. Well, that's about all we have time to cover in this program. See you next month on VideoTec.